Nag-blink na po siya. Ito po.
Hold up, let's know first about the Arduino TRES members.
STEM 11 Prudence. Don Radson B. Costello as circuit builder.
STEM 11 Prudence and Margaret A. De La Cruz as project archivist.
STEM 11 Prudence, I am Jehan Angelo M. Sacro as technical assistant.
Content overview.
Lesson 1 LEDs. We explored the basics of how to control a simple LED light. We began by identifying the parts of the Arduino board and understanding the LED's components, the anode, cathode, and resistor that helps control current flow. Through this lesson, this activity strengthened our problem-solving, observation skills, making us ready for more Arduino projects in the future.
Lesson 2 Buzzer. This lesson focuses on using a buzzer module with the Arduino UNO to create sound through electronic signals. Buzzer is an output device that converts electrical energy into sound, commonly used for alarms, and notifications in electronic projects.
Lesson 3 7 segment. A 7-segment display is an electronic component used to show numbers and some letters commonly found in digital clocks, calculators, and counters. It consists of 7 LED segments arranged in figure 8 pattern that can be turned on or off to form different digits. It can be controlled easily using an Arduino or other microcontrollers to display numeric data in projects. Here are the 2 tasks we've chosen for this video.
There are 5 activities that contain the LEDs.
Activity 1. The Arduino UNO is programmed to make a LED blink at regular interval using the digital write and delay commands. Activity 2. Fading LED. The LED's brightness gradually increases and decreases using the analog write function. Activity 3. Alternating blinking LED. 2 LEDs blink alternately in a loop, demonstrating timing control and multi-output programming. Activity 4. Button-controlled LED. A push button is used to turn the LED on and off, introducing digital input control. Activity 5. LED brightness control using a potentiometer. A potentiometer adjusts the LED's brightness by sending analog input values to the Arduino.
Some challenges we faced were wrong use of wires, uploading errors, and coding errors that caused the LEDs not to work properly. Through testing and adjustments, we learned to be maingat, pasensya, and precise in handling both the circuit and the code.
There are 5 activities that contain the buzzer. Activity 1. Buzzer beep on a button press. The button is connected as an input while the buzzer is set as an output. When the button is pressed, the Arduino sends a signal that activates the buzzer, creating a simple interactive sound system. Activity 2. Melody player with a buzzer. Each note is assigned a specific frequency duration in the code. By sequencing these notes, buzzer can play simple tunes, showing how coding controls timing and tone. Activity 3. SOS Morse code with a buzzer. This activity uses the buzzer to send the SOS signal in the Morse code. Short and long beeps representing dots and dashes demonstrate how Arduino timing function can represent communication signals. Activity 4. Sensitive buzzer alarm. A photoresistor or DR is added to detect light levels. Buzzer turns on when the light intensity drops, simulating a darkness or night alarm. Activity 5. Sound controlled by a potentiometer. The Arduino reads the potentiometer's analog value and maps it to different sound frequencies. The challenges we encounter including wiring errors, loose connections, and incorrect pin placements that cause the buzzer not to work. Face timing mistakes and frequencies mismatch in our code, which affected the sound output. But despite it all, we were able to overcome such challenges with teamwork.
Here are 2 activities from the 7 segment. Each segment is connected to a digital pin, and by setting them to high or low, the chosen digit appears on the display. It helps us understand pin mapping and how Arduino controls visual outputs. The Arduino is programmed to light up digits from 0 to 9 one by one. By looping through segment combinations, we create a counting display that updates automatically. It shows how simple lights can form meaningful outputs through coding. Even with small challenges like display matches and timing delays, we learn to stay patient, think critically, and find solutions together. Let's move on presenting the task.
Task 1. Traffic light stimulation. This task stimulates how real traffic lights work using the Arduino UNO. We use 3 LEDs to represent stop, ready, and go signals. The Arduino UNO was programmed to control the timing of each light using digital write and delay functions. Some challenges we faced were wiring errors and timing adjustments, but we fixed them through testing.
This is the circuit diagram for traffic light. The flowchart shows how the Arduino controls the traffic lights in order. We generated the code asking, design and code a basic traffic light simulation using Arduino UNO and LEDs to understand how timing, logic, and programming work together in real-world traffic systems.
Some challenges we faced were wrong use of wires, uploading errors, and coding errors that caused the LEDs not to work properly. Through testing and adjustments, the circuit and the code.
Task 2. Happy Birthday Melody Challenge Buzzer. Please use coding and tone frequencies to play a simple tune. We programmed the Arduino UNO to play the Happy Birthday melody using a buzzer.
The melody buzzer. The flow of the melody. We asked it to generate a simple Arduino code that plays the happy birthday song using a buzzer on pin 8.
Challenges we encountered were wrong frequencies, timing error, and minor wiring issues. But we solved them through testing and adjustment.
Hello, conclusion.
What are your experiences and what are you looking forward to?
As the main circuit builder sa robotics class, natutunan ko maging patient at maingat sa wiring at coding. Kasi some of those stuff, medyo nakakalito talaga and minsan sala yung na-input ko. So, yun, nagkakamali kami. And nakakahiya. Excited akong matutunan pa yung mas advanced parts ng robotics, like sensors and automation, para makagawa ng mas cool na projects.
Ang experience ko sa robotics class ay kahit na hindi ako palagi nakaka-attend sa robotics meeting, naranasan ko kung paano gumagana ang Arduino at natutunan ko mahalaga ang observation skills. Alam kong mas kailangan ko pang paunlarin ang aking kakayahan. I'm looking forward to learning more about Arduino UNO and how I can make cool projects with it. Gusto kong mas maintindihan kung paano nag-work ang coding at wiring together.
Throughout all my robotic classes, my point of view has really changed. I used to see Arduino circuits as complicated, but now I understand how fun and creative it can be. I learned that robotics isn't just about coding or wiring, but also about problem solving, teamwork, and turning ideas into something real.